Imagine the universe as a grand, cosmic city, a sprawling, silent metropolis of light and structure. Its avenues are paved with darkness, its districts are swirling galaxies, and its skyscrapers are glowing towers of gas. But who are the architects of this magnificent city? Who are its master builders, its tireless artisans? They aren't gods or some unseen force, they're the stars. And this is the story of how these galactic architects build our cosmos. We'll journey into the heart of their stellar construction zones to see how they lay the universe's foundations. We will witness the cataclysmic forges where they craft the very elements of existence. And we'll see how their explosive finales provide the raw materials for new worlds and even for life itself. This is the ultimate story of creation, written in fire and light across the heavens. Every grand structure begins with a blueprint and raw materials. In the cosmic city, you find these in the vast, ethereal clouds we call nebulae. These are the construction sites of the universe, the stellar nurseries where our architects are born. To understand how a star builds anything, we have to travel to one of these nurseries first. Let's journey 6,500 light-years away to a small patch of the much larger Eagle Nebula. Here, we find one of the most iconic structures in the known universe, the Pillars of Creation. In images from the Hubble Space Telescope, they look like majestic smoky towers of gas and dust, light-years tall, rising from a celestial sea. They look solid, like cosmic mountains, but that's an illusion. These columns are made of cool interstellar gas, mostly hydrogen left over from the Big Bang, and fine grains of dust. For decades, we could only see their surfaces, which hinted at the secrets hidden inside. But now, with the infrared eyes of the James Webb Space Telescope, we can finally pierce through that obscuring veil of dust. And what we see is breathtaking. The pillars, which once looked opaque, become semi-transparent, and inside them, hundreds of previously invisible stars are revealed. They are these bright red orbs, the glowing embers that signal the birth of new suns. They're protostars, the infant architects, still wrapped in their dusty cocoons. So how does a cold, diffuse cloud of gas ignite into a star? It all starts with a simple yet powerful force: gravity. A molecular cloud like the one in the Eagle Nebula can just float peacefully for eons. But all it takes is a small disturbance, a shockwave from a distant supernova or the gravitational stirring from passing stars, to upset the delicate balance. Pockets of gas and dust start to clump together, creating denser regions. As these clumps grow, so does their gravitational pull, attracting more and more material. From there, it's a runaway process. The core of the clump becomes a dense, spinning ball of gas, pulling matter into a spiraling disk around it. Friction and intense pressure cause the core to heat up, just like a bicycle pump gets warm when you use it. This hot, dense, embryonic star is what astronomers call a protostar. It's not glowing from nuclear fusion yet, but from the sheer heat of its own gravitational collapse. Recent discoveries from the Webb telescope have even shown us just how chaotic this phase is. Young stars aren't serene infants, they're messy eaters. They periodically shoot out supersonic jets of material that slam into the surrounding clouds, creating glowing, wavy patterns like the bow of a boat slicing through water. In fact, studies of these protostars have detected unexpected bursts of high-energy radiation, something our current models can't quite explain. It suggests these earliest stages of construction are even more violent and complex than we imagined. This is the very first stage of galactic architecture. Gravity, the master foreman, gathering the raw materials and assembling the workforce. Each glowing protostar inside the Pillars of Creation is an architect in training, on the verge of igniting its forge and beginning its life's work. The leap from a warm, glowing protostar to a true star isn't a gradual one. It's a moment of cosmic ignition, a point of no return. As the protostar keeps gathering mass, the pressure and temperature at its core climb to unbelievable levels. For millions of years, it grows hotter and denser until it hits a critical threshold, about 10 million degrees Kelvin. At that temperature, the universe's most fundamental creative process kicks in: nuclear fusion. In the crushing environment of the core, hydrogen atoms are slammed together with so much force that they fuse, forming a new, heavier element, helium. And every time this reaction happens, a tiny amount of mass is converted into a tremendous amount of energy. This is the engine of a star. The outward pressure from this new energy pushes against the inward crush of gravity, striking a perfect, delicate balance. This balance is what defines a star and marks its entry into the longest, most stable phase of its life, the main sequence. Our own sun is a main sequence star and has been for nearly 5 billion years. But a star's life story is determined almost entirely by one thing: its mass. On one end of the spectrum you have low-mass stars like red dwarfs. These are the most common stars in the universe. They're small, cool, and incredibly frugal with their hydrogen fuel. They sip it slowly, burning with a dim, reddish glow. Their lifetimes are almost incomprehensibly long, estimated to be trillions of years, way longer than the current age of the universe. They are the patient, long-lived artisans of the cosmos. In the middle are average-sized stars, like our sun. They burn hotter and brighter than red dwarfs, with a lifespan measured in billions of years. They're the reliable, steady builders, providing the stable energy that complex systems, like planets with life, need to develop. And then you have the giants. Massive stars, those with 8 times the mass of our sun or more, are the titans of the cosmic city. They burn with a brilliant blue-white intensity. Their immense mass creates crushing core pressures, causing them to burn through their hydrogen fuel at a furious rate. While a star like our sun will live for 10 billion years, a massive star's life is incredibly brief, lasting maybe 10 million years, and for the very biggest, only a few million. Their lives are short, violent, and hugely important. These are the architects who work fast and create the most dramatic change. They live brilliant lives and die in spectacular fashion, and in doing so, they become the most important engines of cosmic creation. To understand how the universe gets its complexity, its diversity, and the very elements that make us, we have to follow the life of these magnificent, short-lived giants. For billions, or even just millions of years, a star sits on the main sequence, a stable and predictable architect, fusing hydrogen into helium. But of course, no fuel supply lasts forever. Eventually, the hydrogen in the star's core starts to run out, and that delicate balance between gravity and energy is broken. This is where the star's real craftsmanship begins. Let's start with a star like our sun. When its core hydrogen is gone, fusion stops there. Without the outward push from fusion, gravity takes over, and the core, now made of inert helium ash, starts to collapse. This collapse dramatically heats up the core and the region just outside it, a shell of fresh hydrogen, which becomes hot enough to ignite its own fusion. This new, supercharged shell-burning phase produces even more energy than before. The immense flood of radiation pushes the star's outer layers outward, causing it to swell to hundreds of times its original size. As the surface expands, it cools and glows with a deep red hue. The star has become a red giant. Our sun will do this in about 5 billion years, growing so large it will swallow Mercury, Venus, and possibly even Earth. Inside the red giant, the architect keeps working. The collapsing helium core eventually gets so hot and dense, around 100 million degrees, that a new, more powerful type of fusion ignites. Helium atoms, the ash from the last phase, begin to fuse together to create heavier elements, carbon and oxygen. The star has just learned a new skill. For a low-mass star like the sun, this is pretty much the end of its creative career. Its core isn't massive enough to start fusing carbon into anything heavier. But for massive stars, the story is just getting started. A star more than 8 times the mass of the sun becomes a red supergiant, a colossal beast like Betelgeuse in the constellation Orion. Inside its core, the cycle of collapse, heating, and ignition happens over and over again in a nested, onion-like structure. Once the helium is gone, the carbon-oxygen core collapses, heats up, and starts fusing carbon into neon. When the carbon's gone, the neon core collapses and ignites, forming oxygen and silicon. This cycle repeats, with each stage demanding higher temperatures and lasting for a shorter time. While hydrogen burning lasted millions of years, carbon burning might only last a few centuries, oxygen burning a few years, and the final stage, silicon burning, lasts for only about a day. In this last frantic phase, the star's core forges elements all the way up the periodic table, finally producing the most stable element of all, iron. And with iron, the star's architectural work comes to a sudden, catastrophic halt. Every fusion reaction up to this point released energy, which fought against gravity. But fusing iron doesn't release energy. It consumes it. The iron core is a dead end. The star's forge has gone cold. With its energy source shut off in an instant, the star loses its final battle with gravity. The stage is now set for the most spectacular event in the cosmos. The death of a star isn't an end. It's a transformation, the final, most crucial act of our galactic architect. How it dies, just like how it lived, depends on its mass. And there are two very different paths. First, let's go back to our sun-like star. After its red giant phase, having made carbon and oxygen, it just doesn't have the mass to keep going. Its final act isn't a violent explosion, but a gentle, elegant farewell. The dying star puffs its outer layers away into space. The hot, exposed core, now a tiny white dwarf, lights up this expanding shell of gas, causing it to glow in magnificent, intricate patterns. This beautiful object is called a planetary nebula, a slightly confusing name left over from when early astronomers thought they looked like planets. At the center sits what's left of the star's core, a white dwarf. It's an incredibly dense object, packing the mass of a sun into a sphere the size of the Earth. It's no longer producing energy, just a cosmic ember that will spend trillions of years slowly cooling off. This is the quiet, dignified end for most stars in the universe. But for the massive stars, there is no quiet end. Their death is the most powerful explosion we know of, a supernova. It all starts with that useless iron core. In a fraction of a second, with the furnace shut off, gravity wins. The core, larger than the Earth but containing more mass than our sun, collapses catastrophically. It implodes at over a quarter of the speed of light. The collapse is so violent it crushes protons and electrons together to form neutrons, creating an object of unimaginable density, a neutron star. This new, ultra-dense neutron core is like a brick wall. The outer layers of the star, which were also collapsing inward, slam into this unyielding surface and rebound in a titanic shockwave. The shockwave rips through the star, blasting its vast layers into space with unimaginable force. The star explodes. In that single, brilliant moment, the supernova can outshine its entire galaxy, releasing more energy than our sun will in its whole 10 billion year life. But its true legacy is what it throws out into the cosmos. The explosion itself is so energetic that it triggers a final, furious burst of element creation. While stars forge elements up to iron in their lifetimes, it's only in the fires of a supernova that the universe's heaviest elements, like silver, gold, platinum, and uranium, are made. The supernova scatters these new elements, along with all the carbon and oxygen made during the star's life, far and wide. The architect, in its final self-destructive act, has seeded the universe with the raw materials for the next generation. The exploded guts of a massive star become the enriched gas and dust that will form new nebulae, new stars, and crucially, new planets. The remnants left behind are just as extreme. The core might remain as a city-sized neutron star, so dense that a single teaspoon of it would weigh billions of tons. Or if the star was exceptionally massive, gravity wins completely, and the core collapses infinitely to form a black hole, a point of no return from which not even light can escape. From birth in a nursery of gas to a final, spectacular demolition, the star has done its work. It has lived, forged, and died, returning its creations to the cosmos to begin the cycle all over again. So the cosmic city is constantly under construction. The enriched dust and gas from a supernova becomes the raw material for the next stellar nursery. New stars are born from the ashes of the old, and these second-generation stars are born with a rich inheritance of heavy elements. This cosmic recycling is what makes our own existence possible. Around these new element-rich stars, the leftover material can form not just gas giants, but rocky planets. Planets made of silicon, oxygen, and iron. Worlds with water, with carbon, with all the ingredients for life. The great astronomer Carl Sagan famously said, "We are made of star stuff." And he was being completely literal. The calcium in our bones, the iron in our blood, the oxygen we breathe, every one of those vital atoms was forged in the heart of a massive star that lived and died billions of years ago. We are the living, breathing legacy of these galactic architects. Our bodies are built from the dust of long-dead suns. So when you look up at the night sky, you're not just seeing distant points of light, you're looking at the architects of the cosmos. You're seeing the forges that created the world around you and the very substance of your body. Each star is a testament to a universe that isn't static or empty, but is constantly building, destroying, and reinventing itself. And we are the improbable and beautiful result of their labor. The story of the cosmos is always unfolding, and new discoveries are happening all the time. If you enjoyed this journey and want to explore more of the universe's wonders with us, consider subscribing. Thanks for watching.